When you picture exploring the moon and Mars, your mind probably jumps to massive rockets, cool rovers, maybe even those futuristic habitats. But one of the absolute biggest engineering puzzles we have to solve is something we all do every single day. So let's dive into why getting the plumbing right in space is a mission critical and, yes, a multi-million-dollar quest. Yep, you heard that right. $30 million. And this isn't some far-off concept. This is a real headline about a very real problem with the toilet that's supposed to fly on NASA's Artemis II mission. That's the first crewed flight to the moon in over 50 years. And that single piece of hardware tells you just about everything you need to know about how mind-bogglingly complex space exploration truly is. So that's the big question, right? That's what we're going to unpack here. What on earth makes a space toilet so incredibly expensive and so ridiculously hard to build? Well, the answer involves a little bit of physics, a dash of chemistry, and, as you'll see, some very, very frank feedback from astronauts. Okay, so first things first, we have to get our heads around the fundamental challenge. Here on Earth, we have this silent, invisible force that makes every toilet work perfectly: gravity. But in space, you've got none of it. So what happens when there's nothing to pull everything down? The solution is air. Instead of flushing with water, space toilets are basically just really, really sophisticated vacuum cleaners. They have fans that create suction, which guides everything exactly where it needs to go. Sounds simple enough, right? But making that concept work reliably for months or even years when you're millions of miles from a plumber, that's a whole other story. So, let's meet the star of our show, the Universal Waste Management System, or UWMS for short. This is NASA's next-generation toilet, and it's not just designed for the International Space Station. It's built for those long-haul trips to the Moon and Mars, where every single ounce of weight and every inch of space is absolutely critical. I mean, just look at these numbers. The UMWMS is 65% smaller and 40% lighter than the toilet they're using right now on the space station. Now, when you're launching something all the way to the moon, shaving off that much weight and volume isn't just nice, it's a massive engineering victory. All right, let's take a quick look under the hood. In this diagram, you can see the basics, like the urine funnel and the hose. But the real heart of this entire system is that component labeled DFS, the dual fan separator. That's the engine that creates all the suction. And you can also see the pre-treat tank, which, as we'll find out, is incredibly important. So how does this whole thing work in practice? Well, that powerful fan pulls in both air and waste. The urine gets diverted and mixed with a special chemical to stabilize it so it can be recycled later. Solid waste goes into a bag inside a canister. And one of the biggest upgrades is that the whole system was redesigned to be way more user-friendly for both male and female astronauts. But, a great design on paper doesn't mean a thing until you test it in the real world. So in 2021, NASA sent a UWMS unit up to the International Space Station for a full-blown test run. And, well, almost immediately, things started to go wrong. The very first problem was a showstopper. That dual fan separator, the engine of the whole system, it just wouldn't start. The mission logs showed a locked rotor fault, which is a technical way of saying the motor was completely jammed. The vacuum cleaner wouldn't turn on. And this is where the story gets just a little bit absurd. On the left, you see the incredibly complex high-tech fan assembly, and on the right, that's an astronaut in space, literally trying to unjam it with a regular old vacuum cleaner hose. So much for the glamour of space travel, huh? Spoilers, it didn't work. Okay, so they had a spare fan unit on board, and they swapped it out. Problem solved, right? Nope. A new problem popped up almost immediately. This time, it was with the system that adds that chemical pre-treat to the urine. A tiny but critical sensor inside it failed. And you can actually see the problem hardware right here. Those little fittings on what's called the conductivity sensor were clearly damaged. Now, this sensor's only job is to make sure the right amount of chemical is being mixed with the urine. If that mixture is off, you've got some serious problems downstream. And this is why that tiny little sensor is so unbelievably important. If you add too much chemical, you waste a precious resource that you can't just run to the store for. But if you add too little, that's way worse. You could get fungal growth that clogs up and potentially breaks the station's entire water recycling system, the system that turns urine back into drinkable water. So yeah, a broken toilet could literally threaten the crew's water supply. This timeline really tells the story of the test. After finding a workaround for the sensor, they kept going. But as you can see, it didn't last very long. After just 17 days of limited use, the entire system shut down again. This time, it was a pressure sensor fault. The test was officially over. So, okay, the hardware had some serious issues. But beyond the technical glitches, NASA needed to know one more thing. What was it actually like to use this thing? They sat down with the astronauts for a detailed debrief, and the feedback they got was refreshingly honest. So here they are, the top 3 complaints, straight from the crew. Number 1 was the noise. The official feedback was, quote, "Unit is way too loud." Number 2, odor. Apparently, there were noticeable smells when it was in use. Not great. And number 3 was ergonomics. The seat and the opening were just too big and sat too high to be comfortable. And this chart really puts that noise issue into perspective. The requirement was 68 decibels. The unit they tested on the space station hit nearly 73, and the version for the Orion capsule, the Artemis spacecraft, was almost 76 decibels. That is a huge difference, especially since decibels are measured on a logarithmic scale. In fact, it was so loud that astronauts said they had to wear headphones just to use it. And the feedback got even more specific. Both the men and women on the crew felt the seat opening was too large. One male astronaut just gave up on the seat entirely. And here's a weird one. They all felt like the airflow was weaker than the old toilet, even though the data showed it was actually stronger. It was a perception thing caused by the larger opening. So a fan that won't start, sensors that kept breaking, and a whole list of complaints from the users. Now you might be thinking, what a disaster. But for NASA, this is actually a win. This is exactly why they test this stuff in space. Every single problem is a crucial piece of data that helps them make the final version for the moon that much better. So what's the comeback plan? Well, here it is. NASA is building a new, more robust sensor to install on the ISS unit. They're going to finish the full test run to get all the data they need. And all along the way, they'll keep making improvements based on that crew feedback. All of this leads to one thing: a final flight-ready and hopefully problem-free toilet for Artemis II. Because at the end of the day, this isn't just about building a better toilet for a single mission. The real goal here is to have a toilet that is so reliable, so efficient, and so easy to use that it can support astronauts living and working for months at a time on the moon and eventually on that long journey to Mars. It really makes you think, doesn't it? We just spent all this time talking about a toilet. So what about cooking a meal, or doing laundry, or even just making a decent cup of coffee in the morning? As we push farther and farther out into the cosmos, what other simple, everyday things are going to turn into their own epic engineering quests?